And then share the screen. So an example of continuous random variable is a normal distribution. We call it normal because it has a certain number of properties. These are those properties: that it is bell-shaped, shaped like a bell. The curve is symmetric about the mean. The mean, the median, and the mode are the same. Remember when we were doing in statistics, we had to deal with 3 types of measure of central tendency: mean, mode, and median. Which one should we choose? In a normal distribution, they are all the same. The curve approaches the x-axis but does not touch it. And the total area under the curve is 1, just like we said that the total probability is 1. We are going to look at the graph of a normal distribution. This is the graph. You can see that bell shape is this shape that you are seeing. It's symmetrical because left side and right side are exactly the same. The empirical rule is an important rule that in probability, it applies to normal distribution. You can see the empirical rule here. Some people don't get it well when I am not in action. Is it okay for everybody, or do you like when I write? Let me try writing on Zoom here and you will be seeing. So I will get out of this and use the whiteboard. The reason why I'm doing this is because it helps those who are on Zoom. When I write everything on the board, they cannot see it. So from time to time, I will be writing on Zoom. And if you feel uncomfortable with it, just send me an email and I will change. So let me try today with Zoom. So we have a normal distribution is something like this. It is bell shape. My shape is not very nice. So it's symmetric. At the middle here, we have the median. The median is at the middle, right? Median, we know, is the point at the middle. So we call it mu, is the mean, like in a random variable, the mean is mu. You see that it's at the point where we have the highest probability. So that's why it is the mode. You see at the middle here, we have the highest probability. That's why it is also the mode. The left and right have the same weight. So the average get to the middle. So that's how we say mean, mode, and median are the same. Now, I would prefer to do this empirical rule with an example. You can always go back to the PowerPoint to see that division. So suppose we have a random variable with a mean of 70 and a standard deviation of 5. I have a random variable with a mean of 70 and a standard deviation of 5. Remember when we were doing the Chebyshev's inequality? Here is one standard deviation. The mean here is 75. The mean is 75. So here, what do I have? First standard deviation. Can somebody tell me what to write? I'm sorry, the mean is it supposed to be 75? I told you. Let me write this. The mean is 70. So at the first standard deviation, what should I write here? You see what I'm trying to write? What do you think I should write? One standard deviation more than the mean. Do you see the standard deviation? What is the standard deviation? You don't know what I wrote here? What is the standard deviation? 5. If the mean is 70 plus 1 standard deviation, what do we get? 75. Plus 2 standard deviation, 3 standard deviation. Let's think about this as a score in a test, with the average score to be 70 and the standard deviation 5. Remember, Chebyshev inequality tells us that within 1 standard deviation, it didn't deal with 1. Within 2 standard deviation, we have at least 75. Within 3 standard deviation, we have at least 8.9, and so on. We are going to do the same here. So we subtract 5. So the empirical rule tells us that 68% of values are within 1 standard deviation from the mean. Within 1 standard deviation is here. If there are 68% within 1 standard deviation, 34 will be to the left, 34 to the right. Is that right? Because of symmetry. If there are 68%, we will have 34% here, 34% here. So that's what you had on your go back to the PowerPoint. This is, can you see the board, the PowerPoint? So you have 68% at the first standard deviation. Then at the second standard deviation, we have 95%. Because we already have, I will go back to the whiteboard. I wanted you to see this one. So we already have 34% here. We will write 13.5. I'm not going to write percent. 13.5. So if you add this, this is within 2 standard deviation. So to the left, we have 47.5. To the right, we have 47.5. What do you think we have within 2 standard deviation? %. This is 68%. But what is important for you to know is these breakings that are within here. Now, this is now at the 3rd standard deviation, we have 2.35 here and 2.35 here. So within 3 standard deviation, we have 99.7% of values. Okay? So this is a test that we have given. If I ask you, a score selected at random, what is the probability that it is between 85 and 80? Probability that a test is between 75 and 80. Please think and look on the board and tell me what is the probability that the score is between 75 and 80? Pardon? 13.5%, right? We should be saying probability with percent. I'm not writing percent because with this writing, it will mess it. It's percent. So it's 0.135. Is that right? Can we all see that? Equal to 0.135. Now, if I want the probability that a score X is less than 65. Score is less than 65. What is the probability that a score is less than 65? This one is a little tricky now. The type that you will get on your take-home problem and your exam. Pay attention. Less than 65. Yes. 15.85. Can we say 15.85? No, yeah. Somebody say no, yes. 0.158. Is that okay? Please, everybody should think. I'm not saying yours is wrong, but I want more people to think. So what was his answer? What was your answer? 15.5? 85. So how did you get 15.85? So what is your answer? Another answer? 0.158 is exactly the same thing, right? We understand what I say, exactly the same thing. One is in percentage, the other one is in, something is missing here. Can you think a little bit? Yes. Are we getting that? 0.15 is missing. Do we see what he's talking about? So we still have some small tail here. And my tail here is bigger than this one. It's supposed to be symmetric. It's supposed to look alike. So supposed to go down really much more down. So look at 99%, 99.7% are within 3 standard deviation. There is a little part that is left out, those tails. That is what you will forget your problem and your exam. And I believe you will not forget again now. So there is some 0.15%. So what we can say is that from this 13.5 below, without taking into account the number of standard deviation, we will have 2.5. But if we want to be strict enough, we will say within that standard deviation is 2.35. But from the second standard deviation to the left is 2.5. Please, do we understand what I'm saying here? What I'm saying is this tail is 2.5. But we can no more break it down. And 0.15 is very small. 0.15% is very small. But it will be big if we are discussing billions of dollars. We don't want to forget about it. So if I ask you any range of probability here, you can answer. Can we say that? No. Pay attention to that tail. My tail is not very good. So I will clear all of this and I will make a better one as we move on. So questions, if I ask you, using the empirical rule, this is what you are going to use. Using the empirical rule, you use this one. We are going to learn how to find probability regularly. And sometimes there will be some little difference. But when I ask you to use the empirical rule, you first make this graph and put your numbers there. And what you want to observe here, is, I'll skip this example because it's what I have just done. What you want to observe here is that when we are on the empirical rule, we can only use an integral addition or subtraction of standard deviation from the mean. If I have asked you, for example, what is the probability that a score is between 72 and 83? Empirical rule cannot help you to answer that question. Are we getting that? Empirical rule will not be able to help you. So in general, to resolve the problem of the empirical rule, we use the standard score. I'm going to go a little bit quickly on the standard score because I assume you all have TI-83 calculator. So we are going to use calculator, and I will go first on the mathematical work you are supposed to do and explain how you can use your calculator to answer questions that we have. Are we getting this? So, but I want to explain the standard score. The standard score is used for those who want to use a table. You see, you didn't bring the book. You would have been stuck if you want to use table. How big is this book? You want to be carrying it along? No. It's easier to carry a calculator or your laptop, okay? Because it can do much more than just reading the book. So we are going to skip reading the table, not completely skip. I will tell you what it is about, but I will not expect you to use the tables. So the z-score is useful for reading the table. And what you want to learn about the z-score is the main property of the z-score. The property of the z-score is that it has a mean of 0 and a standard deviation of 1. Whenever you have a random variable, you want to know what is the mean and the standard deviation. Let me use the whiteboard. So, is z equals to score minus mean divided by sigma. This is what we call the standard score. So, if x equals to 82, mean equals to 70, standard deviation equals to 5, then the z-score will be 82 minus 70 divided by 5. It's over 5. This is what we call the z-score. 12 over 5 is what? Use 2.4. This is the z-score. It's good to know. The z-score has mean 0 and standard deviation 1, regardless of the distribution you are using. Look at it. I write this as divided by sigma minus mu over sigma, right? So if I do E of z, because we know linear functions, if I do E of z, it will be E of x over sigma minus E of mu over sigma. Mu and sigma are constant, and this will be 1 over sigma E of x minus mu over sigma. We know that E of x is mu, so this is mu over sigma minus mu over sigma. What should this be? 0. So the mean of a standard score is 0. And the standard deviation of a standard score is 1. The standard deviation for a standard score is 1. So what will be the variance of z? The variance of z will be, this is like a constant times x. So I will write 1 over sigma square times the variance of x. And this one is a constant, just like ax plus b. It is gone for variance. We don't consider it for variance. Now variance is sigma square. So this is 1 over sigma square and sigma square, which is equal. As I told you, these are some mathematics. So we are not really doing mathematics, but if you see, it might encourage you. So what I'm saying here is there is a special type of normal distributions called the standard normal distribution. It is very useful when you don't have a calculator and you want to compute probability. So how does it work? Maybe what I'm trying to tell you here is that I will combine 6.2 and 6.3. 6.2 is z. 6.3 is x in general. And in x, I will give you the mean and the standard deviation. You will do your work. But whenever I tell you that it is a standard distribution, you should remember that even if I don't give you the mean and the standard deviation, the mean is 0 and the standard deviation is 1. Can we go along with that? So a normal distribution x with mean mu and a standard deviation 1, sorry, sigma, is a general standard deviation. And this is how it is. We generally focus on a tail of that distribution. We can call this number A. Or we can have another number here, B. So this is called the area under the curve, which is below A. This is how we write it. This area is the area under the curve, which is above B. And the middle here is the probability that A is less than X, less than B. I am just expressing how equation in probability could be represented on the normal curve. If somebody asks you, find the probability that the random variable is between 3 and 5, it means it is the middle part. Not the middle actually, but it's a portion inside. If somebody asks you, find the probability that X is less than a certain number, it is the lower tail of the graph. X is greater than is the upper tail of the graph. So whatever it is, the question you are asked, if you don't have calculator, which we have, but you should know what to do if you don't have calculator, you will do that probability that A is less than B is equal to probability that A minus mu or sigma is less than Z, less than B minus mu over sigma. Okay. So we say we standardize the random variable because we want to go to the table. Table is here. Most of you have your textbook. You have the table right here. All of these, the tables are here. So this first one is the normal distribution for the left, the normal distribution for the right, the t distribution. We are going to learn all of those. But because you have calculator, we are not going to be moving along with this book all the time. We're going to be using the calculator. So let's go back to the PowerPoint. Just so that you know what the Z distribution is. Find the area to the left of Z equals to -1. This is a question. The probability that standard storm is less than what? Less than -1. This is 0. This is -1. This is 1. Somebody tell me what is the area here, just to check. The normal distribution, yes. 0.34. 0.34, right? Do we understand where it is coming from? From the empirical rule, it's about this. It's not exactly this, but it's close, very close to this. Now, the question here is the area to the left of -1. Probability that Z is less than -1. What will it be? Can somebody tell us without looking at anything at this point? This left part is 50%. The right part is 50%. So if this is 34%, what should be this? Yes? 0.16, can we see it? Left from the middle is 50%. Right is 50%. So, by the empirical rule, we know this. So now, what I want you to see is how we can read the table to get that. So you will take your table. The table is bigger than this, but this is a small portion of that table. So the Z is like that. You will identify -1. You see here, -1.0. The second decimals are here, up here. So because it is -1, it's 0.00. So negative 1.00, so we are here. 0.1587. Do you see how close it is to 0.16? So the empirical rule tells us it's 0.16. Now, please take your calculator. Let's use calculator to do the same thing. Calculator. Using calculator, if you have your TR-83, 84 calculator, we want to use it to find the probability that Z is less than -1. So you go to second function, distribution, like we did for binomial. You know, second function distribution, order VARS. And then the first one is normal PDF. Forget that, we don't use that. Then we want normal CDF because we are accumulating, it's the total area to the left of -1. Normal. What is the lower value? What is the upper value? What is the mean? What is the standard deviation? Anybody has a calculator asking for lower value? Lower value, yes, somebody. Some of you have. So you don't have problems. Negative, okay, yeah, you will have problems here. Lower value is -infinity. But you cannot write -infinity. Just write -1000. That is a very small value to represent -infinity. We are going to get to everybody. So for other people, you will have normal CDF and a parenthesis will open. So this is what you should be thinking about each time. This expression represents all the type of equation you have. So this one is like A is -infinity and B is -1. Equation like this. Z is less than -1. The upper value, B is -1. A is -infinity. For that -infinity, do you know what you should do? Just subtract 10 standard deviations from the mean. Because we know from the empirical rule that above the 10 standard deviation, there is almost nothing, if you could remember. We say that if this is a normal distribution, within 3 standard deviations, we have covered the entire, almost the entire set of values. You get what I'm trying to say here? I told you that within 3 standard deviations, we have about what? 99.7% of value. So do you think we will get more after the 4th, 5th, or 6th standard deviation? We may not get anything. So to resolve the problem of you are writing -infinity, I can show you one way of putting it. If you have, just write -1000. For Z, always write -1000. But even -10 will work. And I usually tell students just write -1 million. Understand what I'm trying to say, and that will help you. It means I want to go to -infinity, but you typing -infinity, the calculator will. So just type minus. So for Z now you write -1000. So you will write -1000 and let me put it this way. You are going to write A, B, U, sigma. So for this case, A is what? -1000. B is -1. Mean is 0. Sigma is 1. But if you don't put this one on your calculator and you just do this, it will work. Because if you don't tell them the mean and the standard deviation, calculator assumes is the standard normal distribution. So for standard normal distribution, there's not much problem. But for a regular distribution, you have to put the mean and the standard deviation. For those of you with the calculator, it already have 0 and 1 as default. So you can leave it like that when we are at Z. So I want to think somebody can tell us what you get. You put enter to get. If you have trouble, let me know. 0.159. So we can use the empirical rule. It will give us a rough value. We can use the table, we can use the calculator. Calculator it looks difficult now, but very soon you will feel like, wow, it's so good. Okay, it's going to solve a lot of problems. Now, if we want the probability that z is greater than a number, here we want what? Probability that find the area between 1 and 2.7. 1 and 2.7. This is 0. This is 1. This is 2.7. Do you think we can use the empirical rule for this one? Can we use empirical rule? We cannot use empirical rule because empirical rule goes only for 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. Okay, it doesn't go in between. So we want the probability that 1 is less than z less than 2.7. Calculator. I can spend like 10 minutes or 15 to show you how to read the table to write this. But for just information, as you are using your calculator, to do the table, you are going to write that is probability that z is less than 2.7 minus probability that z is less than 1. Because the table is only giving you the tail. It's only the table cannot change, it's fixed. So they only put values for tails. So we change each question into tails, left tail actually. You see what I've done? So what I've done is that to find this, take from here and subtract this one, you are left with, and subtract this one, you are left with that. Reading the table, you will be writing all that and the reading, writing. But with your calculator, what do you get? If you have trouble using calculator, let me know. Can you say it again? Anybody else has this? Somebody is not having the right, this one. So this is how you will do with your calculator. Sorry, with the table. So you are in the PowerPoint. I am teaching on the PowerPoint as if you don't have calculator. My note is very general, but it's not the same for you because we are going a little bit fast. We are going to cover 10 chapters, but we want you to learn more. Nobody will be expecting you to be doing this manual calculation in any office or in any work. They will expect you to either to use your Excel or to use your calculator. Do we get that? So this is how you will do using the table. So we can do all of this. So why not go to 6.3? Let's give ourselves, let's give ourselves 5 minutes more and then we can stop. And we will continue on Thursday, right? Today is Tuesday, right? So I don't like finishing the time because I want to give you the time to play. So let's look at some of the problems that are here. Let's look at this problem. I hope those who are on Zoom, you should be following us. Use your calculator and make practice as well. So let's have a normal distribution with mean 10 and standard deviation 2. Find the probability that an X value selected at random from this distribution is between 11 and 14. So that means find the probability that X is greater than 11 and less than 14. So you use your calculator. Can you use your calculator to do that? Mean is 10, standard deviation is 2. It's by practicing that you will remember how to work with it. So anybody have trouble to find 0.286? Do you have 0.286? Okay, so let's look at how you were supposed to do without calculator. You have to convert each of these values in standard form. You don't need to really write this. because anyway, maybe you might need it some, I don't know. But yet, you have to just convert it in standard form, convert 11, convert 10, and then put it on in standard form. And you read the table to get the answer. Inverse normal. I will do 1 or 2 examples of inverse normal. Suppose I want you, look, suppose I like giving example from the PowerPoint so that you feel good when you get it right. This is not an easy one. Anyway, suppose I want you to find this value Z so that this area is 0.05. I want you to find Z so that this area is 0.05. That's the question here. If we were to use the table, if we were to use that Z table, the probabilities are here. I will look inside here for 0.05, and then I will come to this with what is up here to identify this Z value. Okay? But with calculator, you will do the same thing. Go to distribution, second function, distribution, find Z so that the area to the left of Z is 0.05. I'm just writing so that you use your calculator. So we want to find Z so that we have this. So you go inverse normal. If you go to distribution, you have normal PDF, normal CDF, inverse normal. Do you see inverse normal? So you click that inverse normal. For most of you, you will have inverse normal and open the bracket. If you just put 0.05, it will give you the answer because it assumes it's the standard normal distribution. But those who have other information, we will have area. That area is area to the left always, even if it's not written. So you just put 0.05 area. The mean is 0, standard deviation is 1. Can somebody tell us what you get? Negative 1.645. Negative 1.645. Okay. So let's just suppose the question was what is the area to the right? So that, what is Z? So that this area is 0.05. Look at what will happen. Because of symmetry, if this is negative 1.645, then this will be 1.645. Because this area is the same as that, and because of symmetry. But let's find this using calculator. It's not for the sake of this, it's for other questions you may have. If you want the area to the right, always change. If this area is 0.05, what should be the left part of it? If total is 1. If this is 5%, what will be the left part of it? 0.95. So put 0.95 instead of 0.05. Please pay attention to this because you will have that kind of question when I will ask you area to the right, and you have to think that whenever you have area to the right, find the left of that point, which is 1 minus what you have. We are going to come back to this with some more examples, but practice with homework of 6.1, 6.2, and 6.3. The reason why you feel like it is a lot of section, because I skip all the mathematics, because you can use your calculator. Try it. I think everything is due next week. So on Thursday, we will work more of those problems from your homework. That is what we have to understand. So what I'm saying is start doing the homework. Don't feel like you're not doing the chapter. But you can do homework for 6.1,
It's essentially empirical rule. When we have that 6.2 is only about G distribution. Mu 0, standard deviation 1. 6.3, more general. Use your calculator.